Hi everyone, welcome to My Max Academy. In this video, we'll start with the chapter Coordinate Geometry, which is chapter 7 from your 10th standard CBSE Mathematics. So in Coordinate Geometry, we basically study about position of a point in a plane using ordered pairs of numbers. And that ordered pairs of numbers are called as coordinates. Right? They're called as coordinates. So let me draw the x-axis. This is the x-axis and this is the y-axis. Right? So this is called as x dash, y and y dash. So these two perpendicular lines are called as, so this is called as x-axis, this is called as y-axis. The horizontal line is called as x-axis, vertical line is called as y-axis, and they are perpendicular. And these two axes are called as coordinate axis. Coordinate axis. Both x and y axis are called as coordinate axis. X and y axis. X and y axis, they are called as coordinate axis, and the points where the x axis and the point where x axis and y axis meet, this point is called as origin, and it is denoted by the ordered pair 0, 0. This is your origin. So this is your origin. Fine. And this is called as positive direction of x-axis, this is negative direction of x-axis. So this is called as positive direction of x-axis. So I can write it here, positive direction of x-axis. And this is called as negative direction of x-axis. Negative direction of x-axis. And this one is called as positive direction of y-axis. This is positive direction of, I can say positive, I can write it positive direction of y-axis. And this is called as negative direction of y-axis. Right? So this is your positive direction of x-axis, negative direction of x-axis, positive direction of y-axis, negative direction of y-axis. So these you might have studied. I'm just trying to refresh what you had studied in 8th as well as in 9th standard. Then any point, so here we can have, see, this is 1, 2, 3, 4, 5. So similarly here you have -1, -2, -3, -4 and so on. So here it is 1, 2, 3, 4, 5, and here you have -1, -2, -3, -4 and so on and so forth. Fine. So now again, so these two lines, so this is called as a plane. This is called as our two dimension. This is called as two dimension, and it is a plane where we have the two lines which are called as coordinate axis, and these two lines, they divide the entire plane into 4 quadrants or 4 parts, and each part is called as quadrants, right? So it divides into 4 quadrants. So this is first quadrant. This area, this region is called as first quadrant, and this is called as second quadrant, and this region is called as third quadrant, and this one is called as fourth quadrant. So these two lines are the coordinate axis. They divide the entire plane into 4 parts, and each part is called as quadrant, and there are 4 quadrants. So first quadrant, this is your first quadrant, which is this region. Then second quadrant is this region, this is your third quadrant, and this is your fourth quadrant. And these lines, the x-axis line, the positive direction of x-axis, positive direction of y-axis, negative direction of x-axis, negative direction of y-axis, these are not part of any quadrants. These lines, they do not belong to any quadrant. They are not in the quadrant. So basically your entire plane is made up of quadrants and these two axis, x-axis and y-axis. The entire plane is made up of 4 quadrants and these 2 lines. And again, as I said, this coordinate geometry is about studying position of the point in a plane. And then also in this chapter we'll study about distance between the 2 points, and then we will also study about the area of the triangle, and also we will study about finding the coordinate of the point which lies between any 2 given points, or line segment that connects any 2 points and things like that. So with this we have the plane which is divided into 4 quadrants. Now let's take position of any particular point. Suppose if I take this point, suppose if I take the point here, say this point is basically, if I call that point as P, this is basically the position is what, x is 3 and your y is 2. So this is called as the point is 3, 2. This is your point 3, 2. This point P is denoted by the coordinate. This is called as coordinate, which is 3, 2, which means the first one is called as x coordinate, which is 3, and this is called your y coordinate, which is 2. So if you want to mark or plot the point 3, 2, we will go 3 on the x-axis, then we'll go up 2 on the y-axis, because both are positive. So positive 3 and positive 2. Positive 3 on the x-axis, positive 2 on the y-axis, both meet at this point. So this is the position of the point 3, 2. And this is called as ordered pair. And it is also called as coordinate. 3, 2 is called as coordinate. Coordinate of point P. And this 3 is called as x coordinate. X coordinate. And x coordinate is called as abscissa. X coordinate is called as abscissa. And this 2 is called as y coordinate. Y coordinate, and is also called as ordinate. The other name for y coordinate is ordinate. So 3 is called as x coordinate. The other name for x coordinate is abscissa, and 2 is called as the y coordinate, which is called as ordinate. Right. So these are the simple concepts, or the initial concepts that we need to know about the coordinate geometry. Fine. So all of you can pause the video and take the notes. I will now move on to finding distance between 2 points in a plane. Right. So let me erase this. So now let's again take our, so this is our x-axis, this is our x dash, this is our y-axis, this is y dash, and this point is our origin O. The coordinate is 0, 0. X coordinate is 0, which is abscissa. Y coordinate is also 0, which is ordinate, and 0, 0 is called as coordinate of origin, and this point is called as origin. Now suppose if you have a point here, suppose if you want to find the distance between 2 points on the plane, say this P of x1, y1 is one point, x1, y1, and there is another point Q whose coordinate is x2, y2. So there are 2 points, P of x1, y1. P is a point of x1, y1. And Q is another point which is x2, y2. Then if you want to find the distance between the point P and Q, or if you want to find the length of the line segment PQ, which is this, if you want to find the length of the line segment PQ or QP, then the distance between these 2 points is given by the formula D is equal to, or the distance, or PQ, you can say distance PQ is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. For finding the distance between the point P and Q, the coordinate of P is x1, y1, and coordinate of Q is x2, y2. then the distance between the 2 points PQ or length of the line segment PQ is defined as square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Fine. So that's how we have the distance between 2 points. Fine. Now let's go to one small example. Suppose if this point is say 3 comma 2, and suppose this point is, for example, 5 comma 7, and if you want to find the distance between these 2 points, so P is what? P is P of 3 comma 2, which means the coordinate of the point P is 3 comma 2. That's how we denote the coordinate, and Q is 5 comma 7. Now if you want to find the distance between these 2 points, so this is our x1 y1 x2 y2. You can take anything as x1 y1, you can take the other way also. Anything can be taken as x1 y1. If you take it, this can also be taken as x2 y2, this can also be taken as x1 y1, doesn't matter. Also this formula can also be written like this: x1 minus x2 the whole square plus y1 minus y2 the whole square. It doesn't matter because it's whole square. So if you swap these two, you'll get a negative. Negative of square is positive. So whether x2 minus x1 the whole square or x1 minus x2 the whole square, both are same. So mostly we will follow this formula. Both are same. You can use anything, because as I said, you can even swap the points. It doesn't matter. You can call this as x2 y2 and this can be called as x1 y1. Fine. So we'll mostly use this formula. So we'll stick to this: x2 minus x1 the whole square plus y2 minus y1 the whole square. Now what is our distance PQ? The length of PQ is square root of x2. x2 is 5 minus x1 is 3 the whole square, right? x2 minus x1 is 5, x1 is 3 the whole square, plus y2 is 7 minus y1 is 2 the whole square, right? So now, so we have substituted these points in this formula. So that is equal to square root of 5 minus 3 is 2 square plus 7 minus 2 is 5 square. So you get square root of 4 plus 25, which is square root of 29. That is your PQ. The length of PQ is square root of 29 units. Fine. This is how we find the distance between the 2 points in the plane. Fine. So again we just substitute these in this formula and then we evaluate and find the value of the distance between P and Q. So all of you can pause the video and take the notes. I will erase this and we can go to example 1 in your textbook. So our example 1 is, example 1 in page number 158 in your textbook. So page number 158 in your textbook is, it says that example 1 says this: do the points 3, 2, minus 2, minus 3 and 2, 3 form a triangle. If so, name the type of the triangle formed. So what it is so there are 3 points that are given. Suppose we call that as P, Q or not. P of, so what is given in the question is P of 3, 2, Q of minus 2, minus 3 and R of 2, 3. So these are 3 points which are given distance. These are 3 points. We need to check whether these 3 points form a triangle. Whether these 3 points form a triangle. Suppose if you have a triangle like this. Suppose if this is P, this is Q, this is R. So when can we form a triangle when you have 3 points? Is when it satisfies the triangle inequality. What does triangle inequality say? Sum of any 2 sides of the triangle should be greater than the third side. So which means when you add PQ and QR, the addition of PQ plus QR should be greater than PR, as well as if you add these two sides, QR plus PR, that should be greater than PQ, and if you add these two sides, PR and PQ should be greater than QR. So we should make sure that whether these three given points, they satisfy triangle inequality. What the triangle inequality says? Sum of any two sides of the triangle should be greater than the third side. Sum of any two sides of the triangle should be greater than the third side. That's what we are going to verify here. So for that we should find what is PQ, what is QR, what is PR. Which means we should find the distance between P and Q, Q and R, and P and R. Fine. So let's draw that. So this solution, we have to check whether they form the triangle. If they form the triangle, then what is the type of the triangle? So these 3 points will form the triangle if they satisfy the triangle inequality, and that is sum of two sides of the triangle. Sum of any two sides of the triangle should be greater than the third side. So let's try to find the length of each side. Length of PQ, QR, and PR. Let's find that. So solution is, let's find PQ. So what is PQ? That is the distance between these 2 points, P and Q. So suppose if I take this point is 3, 2, and this point is minus 2, -3, and R is 2, 3. R is 2, 3. Those are the 3 points that is given. Let's find what is PQ, distance between these 2 points. So P is this point, Q is this point, and R is this point. Now what is PQ? So if you take this as x1, y1, x2, y2, then we get the formula for distance is what? X2 minus x1 the whole square plus y2 minus y1 the whole square. So x2 is minus 2. So minus 2 minus x1 the whole square, right? x2 is minus 2 minus x1 is 3 the whole square plus y2 is, this is y2, minus 3 minus y1 is 2 the whole square, right? So this gives the distance between P and Q, that is equal to square root of minus 2 minus 3 is minus 5 the whole square, plus this is also minus 2 minus 5 the whole square. So you get square root of minus 5 the whole square is 25 plus 25, which is square root of 50. Right? That is your PQ. So we have found the length of PQ using the distance formula between P and Q. So similarly now we should find what is QR. What is the distance between QR? So what is our QR? So Q point is minus 2, minus 3. Your R point is 2, 3. Now let's find the distance between QR. So we'll take this as x1, y1. So x1 is minus 2, y1 is minus 3. x2 is 2. This is your y2. Now what is QR? Again square root of x2 minus x1. x2 minus x1 the whole square. So x2 is 2 minus x1. x1 is minus 2. So minus of minus 2. So you have to be careful here, the whole square. See, x2 is 2 minus, this minus is in the formula of this minus. Then x1 is minus 2. So x2 minus x1 the whole square. So you will get two negatives. The one negative is what is there in the formula. The other negative is the coordinate x1. So you may make this mistake here. You may miss one of the minus signs. So you have to be careful here. Then plus y2 minus y1. y2 is 3 minus y1. y1 is minus 3. So minus of minus 3 the whole square. Right? So y2, which is 3 minus y1 is minus 3 the whole square. We are substituting this formula. So this is our distance formula between 2 points. So that is equal to square root of 2 plus 2. 2 plus 2 is 4 square plus 3 minus into minus plus 3. Right? If you want, I can write one more step because some people are still not comfortable with dealing with signs. 2 minus of minus plus 2 the whole square plus this becomes 3 plus 3 because minus into minus plus 3 the whole square. So that is equal to square root of 2 plus 2 is 4 square plus 6 square. The square root of 4 square is 16, 6 square is 36. So if you add, you get 52. So that is your QR. Length of QR is 52. So this is 52. Now we should find the last side PR. Let's find PR. PR is what? What is P? So the point P is 3, 2, and our r is 2, 3. Let's find PR. We'll take this as x1, y1, x2, y2. So you can take anything as x1, y1, x2, y2. Right? You can call this as x1, y1 and this as x2, y2. Fine. So now that is square root of x2 minus x1. x2 is x2 minus x1. So x2 is 2 minus x1 is 3, the whole square, plus y2. y2 is 3 minus y1. y1 is 2, the whole square. So that gives you square root of 2 minus 3 is minus 1 square, plus 3 minus 2 is 1 square. So you get square root of minus 1 the whole square is 1 plus 1, which is square root of 2, which is your PR. Now we have got the length of 3 sides, whether these 3 sides form a triangle. Whether these 3 sides form a triangle. For that, we have to check whether the sum of 2 sides of the triangle, sum of any 2 sides of the triangle should be greater than the third side. That is the triangle inequality, right? So now, which means if you add any two, which means if you add this and this, that should be greater than this. Now, see, approximately, if you write, what is your root of 50? Root of 50 is 7 point something. Square root of 50 value is 7 point something, because square root of 49 is 7. Square root of 49 is 7 means square root of 50 should be more than 7. Definitely it is more than 7. So 7 point something. Right? You not find the exact value. You can say it is 7. If you want, you can also find using the division method, you can find the square root. 7 point something. So this will be again, this will be square root of 52. This will also be 7 point something, because this is also greater than 49. So 7 point something. It cannot be 8 point something, because 60 square root of 64 is 8. This is not 64, it is 52. This is also 7 point something. Then this is root 2 is 1.414. We know that, or it is 1 point something. If you don't know, 1 point something. Right? 7 point something, 1 point something. Right? We know root 2 is 1.414 if you want. Now if you add the two sides, suppose if you add 7 point something plus 7 point something, will be 14 point something. And that is definitely greater than 1. So sum of these two sides, PQ plus QR, is greater than PR. Also we should check for all the cases. Then sum of this and this should be greater than this. This is 7 point something, this is 1 point something. That will give you 8 point something, and 8 point something is greater than this 7. So this plus this is also greater than this side, which is PQ. Fine. Now if you add these two, that is also should be greater than this one. So which means this is 7 point something, this is 1 point something. 7 point something plus 1 point something will be 8 point something, and 8 point something will be greater than 7 point something. So which means what we have checked? We have checked the triangle inequality. Right? So which means sum of any two sides is greater than the third side. So we'll say sum of any two sides is greater than the third side. Third side. Sum of any two sides greater than the third side. Therefore, PQR, the points PQ and R form a triangle. Therefore, the points P, Q, R form a triangle. Form a triangle. This form. They form a triangle because they satisfied triangle inequality. Sum of any two sides is greater than the third side. Any two sides means if I add any two sides, that should be greater than the third side. If I add this and this, it should be greater than this. If I add this and this, it should be greater than this. Fine. Now, so the first part is that what they say, that do these points form a triangle? So we have said yes, a triangle is form a triangle. Now, what type of triangle it is? Now, what type of triangle means we have to check whether it is scalene triangle or isosceles triangle or equilateral triangle or right angle triangle. Right? Isosceles triangle means two sides should be same. This is root 52, root 50, root 52, 2. So the two sides are not equal. So they are not isosceles triangle. Equilateral means all the three sides should be equal. They are also not equal. Not equilateral triangle. Scalene means all the three sides should be different. Yes, it's a scalene triangle. As well as we can check whether it is a right angle triangle. So what is the right angle triangle? So sum of the squares of the two sides is equal to the square of the third side. Then we can say That is a right angle triangle. So which means let's check whether the square of sum of the squares of two sides is equal to third side. Now which is the greater side? So which is greater here among these three? 52 is the greatest. So this may be an hypotenuse. This may be a hypotenuse, which means we should check whether square of this plus square of this is equal to square of this, the greater side, right? So which means let's try to find what is our PQ square plus PR square. That is equal to how much? What is PQ square? That is root 50 the whole square. Your PQ is root 50, so your PQ square is root 50 the whole square plus PR is root 2, which is root 2 the whole square. So you get 50, square root of 50 square is 50, square root of 2 is 2, so you get 52. And that can be written as square root of 52 the whole square. 52 can be written as square root of 52 the whole square, and square root of 52 is what? QR. So QR square. Root 52 is QR, so it becomes QR square. So which means PR square plus PQ square plus PR square is equal to QR square, which means the sum of the squares of the two sides of the triangle is equal to the square of the third side, means then by converse of Pythagoras theorem we say it's a right angle triangle, right? So we'll say by converse of Pythagoras theorem PQR is a right angled triangle. Right angled triangle. It's a right angle triangle, and we can also say it is right angled at what? Or we can say right triangle. What? It's a right angle triangle. And what is a right angle? Which is 90 degree. See, which is your hypotenuse? QR is the hypotenuse. And which side is opposite to QR? So this is your hypotenuse, QR. This is your hypotenuse. So which means this is your 90 degree. This is 90 degree. So which means it's a right angle triangle. And you can say comma, and our angle P equal to 90 degrees. Angle P equal to 90 degrees, because QR becomes the hypotenuse. And how do we know QR is hypotenuse? That is the longer side. Compared to all these three, root 52, root 52, root 50 and root 2, which is the greatest side? Root 52. So the sum of the other two smaller sides, if that is equal to the longer side, square of the longer side, then we say that triangle is a right angle triangle or right triangle. So PQR is a right triangle at P. Right? So all of you can pause the video and take this notes. We'll go to the next problem, example 2. Erase all this. So in example 2, so what is given in example 2? The given is, show that the points, so they have given 4 points, show that the points, we can call them as A of 1, 7, and then B of 4, 2, then C of minus 1, minus 1, and D of minus 4, 4. There are 4 points. These are 4 points, given points. We need to check whether they form vertices of a square. So we have to check. What you have to check? We are not proving. We are checking whether it's a square. To check whether ABCD is a square. Whether ABCD is a square. Fine. So now let me erase these. Let me draw the diagram here. Suppose if we have like this, I'm drawing a square, but we have to prove that it's a square. So this A is 1, 7. B is, this is A, this is B, 4, 2. Then C is minus 1, minus 1, and D is minus 4, 4. Now always given the take the points in the given order. So this is for the first point given, second, third and fourth. You can name them as ABCD, but name it in the order in which it is given. The first point given in the question, second point, third point, fourth point means we should name it as ABCD, or you can name it as PQRS. And then you plot them and always write it in a cyclic form, which means after A, you can write B here, C here and D here. Don't write A, B, then don't write C here. Your C should be adjacent to B. It cannot be opposite to B. So you can write it as A, B. You can choose anything as A. If you choose this as A, then A, B, C, D, or you can say if this is A, you can go this way also. A, B, C, D. But go or plot them or mark them in a cyclic order. And don't put A, B, then C, D. That's not in cyclic order. A, B, then C should come here. C cannot come here. C, then D. Right? That's very important. Now we should prove or check whether it is a square or not. When do we call this as a square? We have to use the properties of square. So what is one of the properties of, or the basic definition of square is what? Or the basic necessity for a quadrilateral to be a square is all these four sides should be equal. All these four sides should be equal. That is the first condition that we need to check, which means AB should be equal to BC, should be equal to DC, should be equal to AD. We have to find the length of these. We have to find AB, we have to find BC, we have to find CD, we have to find DA, and check whether all the four are equal. Now, if all the four are equal, then we cannot claim that it's a square. We cannot claim that it's a square. Then it can be a rhombus also, right? For rhombus also, all the four sides are equal. Then we can either check whether each angle is 90 degree, or even if one of the angles is 90 degree, we can prove all the angles as 90 degree. We have to show at least one angle is 90 degree. If one angle is 90 degree, then every angle will become 90 degree. Or we have to check whether the length of the diagonals are equal. Whether length of the diagonals are equal. So since we are dealing with the distance formula, we will try to check whether the length of the diagonal AC is equal to BD. So if all the four sides are equal and if the diagonal lengths are equal, the two diagonals which are AC and BD, then it becomes a square. Because for rhombus, all the four sides are equal, but the diagonals need not be equal. But if the diagonals are equal, then it must be a square. So we are going to check these two conditions. So let's find a solution. Let's find all the distance between or the side of each side of this quadrilateral. We are going to prove that it's a square, right? So let's take A is 1,7 and B is 4,2. Let's find what is AB. What is AB? That is the distance between these two. This is x1, y1, x2, y2. So square root of, let's apply the distance formula. x2 minus x1 the whole square. x2 is 4 minus x1 is 1 the whole square. So x2 minus x1 the whole square plus y2 which is 2 minus y1 which is 7 the whole square. I'm substituting this formula. This is our distance formula, right? This is our distance formula. So that becomes square root of 4 minus 1 is 3 square plus 2 minus 7 is minus 5 the whole square. So that becomes square root of 3 square is 9 plus 5 square is 25. That becomes square root of 34. That is your AB. That is the length of the side AB. Now let's find what is BC. What is BC? Now BC, to find BC, I will write the B and C points. So B is 4,2 and C is minus 1, minus 1. Now we have to find BC. So again we will take this as x1, y1, x2, y2. Fine. So what is our formula? Distance formula is square root of x2 minus x1. x2 is minus 1. x2 minus x1. x1 is 4. The whole square plus y2 minus y1. Right? y2 minus y1 the whole square. So y2 is minus 1. y2 minus y1. y1 is 2. The whole square. So now if you simplify this, you get square root of minus 1 minus 4 is minus 5 the whole square plus minus 1 minus 2 is minus 3 the whole square. So that gives you square root of, this is 25 plus 3 square is 9, minus 3 the whole square is plus 9. So you get 34 square root. Your BC is also the root of 34. Now let's find what is, so we have found AB, we got root 34. We found BC, that is also root 34. Let's find CD. So C is minus 1, minus 1, D is minus 4, 4. Let's find CD. CD length is square root of, so this is x1, y1, this we can take it as x2, y2. So x2 minus x1, x2 is minus 4 minus x1, x1 is minus 1, so minus of minus 1, the whole square. Right? If you want, I can put a square bracket. So x2 minus x1 the whole square plus y2 is 4 minus y1 is minus 1 the whole square. Right, so what it becomes? So that becomes equal to square root of minus 4, this is minus into minus, plus 1 the whole square plus 4 into minus plus 1 the whole square. So what do we get here? So that is equal to square root of minus 4 plus 1 is minus 3 the whole square plus 4 plus 1 is 5 the whole square. So we get square root of minus 3 the whole square is 9, 5 is 25, that is your CD, therefore CD is also 9 plus 25 is root 34. So we found CD, that is also square root of 34. Now let's find what is our DA. Right, so we have found this also. This is also coming root 34. CD. Now let's find what is DA. What is DA? Let me write here. So DA. So let's write what is D. So point D is minus 4 comma 4 and A is 1 comma 7. So we can take this as x1 y1 x2 y2. Fine. Now let's try to find the distance DA. DA is what? DA equal to square root of x2 minus x1 the whole square. x2 is 1 minus x1 is minus 4 the whole square. Right? x2 which is 1 minus x1 is minus 4 the whole square plus y2 is 7 minus y1 is 4 the whole square. So that is equal to square root of 1 plus 4 the whole square plus 7 minus 4 is 3 square. That becomes square root of 1 plus 4 is 5. 5 square is 25 plus 9. That is your DA. So your DA becomes 34 square root of. So this is also 34. Now all the four sides are equal. AB is also root 34, BC is also square root of 34, CD is also square root of 34, DA is also square root of 34. So when all the four sides are equal, then it is either a square or a rhombus. But we must prove that it is a square. So then what we can do, we can find the length of the diagonals. Let's find this length, AC and BD. If AC equal to BD, if the length of the diagonals are equal, then and the four sides are equal, then it becomes a square. So let's find what is AC. Let's find AC. Further, let's write A. A is 1 comma 7 and C is minus 1 comma minus 1. I'm taking A point and C point. Let's find the distance between A and C. So what is AC distance? So we can take the x1, y1, x2, y2. So what is that? x2 minus x1. So x2 is minus 1 minus x1 is 1 the whole square plus y2 which is minus 1 minus y1 which is minus 7 the whole square. So x2 minus x1 the whole square plus y2 which is minus 1 minus, this minus is in the formula, then y1 is 7. So that equal to square root of minus 1 is minus 2 the whole square plus minus 8 the whole square. So that will give you square root of minus 2 the whole square is 4, 8 square is 64, you get 68. You get 68 square root of. So that is your AC. Your AC is square root of 68. Now let's find what is BD. So for BD, B is what? The point B is 4 comma 2 comma our D is minus 4 comma 4. Minus 4 comma 4. Let's now find the distance between BD. So we'll take this as x1, y1, x2, y2. Right? So BD is square root of x2 minus x1. So minus 4 minus this 4, x2 minus x1 the whole square plus y2 minus y1. Y2 is 4 minus y1 is 2 the whole square. So that gives you square root of minus 4 is minus 8 square plus 4 minus 2 is 2 square. That gives you square root of 64 plus 4 which is square root of 68. That is your BD. So your BD and AC are equal. Diagonals are equal. All the four sides are equal. Which means we have AB is equal to BC is equal to CD is equal to DA. Which means all the sides are equal. Also AC is equal to BD. right? So all sides are equal, and diagonals are equal, all sides are equal, which is this, and diagonals AC equal to BD, length of the diagonals are equal, therefore ABCD is a square. So therefore we can say that ABCD is a square. So therefore ABCD is a square. We have proved that ABCD is a square. This is ABCD is a square. Fine. Right. So all of you can pause the video and take the notes. I will stop this video here. You can watch my next video for the continuation of this. Thank you for watching. See you all in the next video. Thank you.